Assembly language. Each family of processes has its own set of instructions for handling various operations such as getting, displaying, performing various other jobs. These set of instructions are called machine language instructions. Having an understanding language makes one aware of how programs interface with OS, processor, and BIOS, how data is represented in memory and other external devices, how the processor accesses and executes instruction, how instructions access and process data, how a program accesses external devices. Other advantages of using assembly language are it requires less memory and execution time. It allows hardware-specific complex jobs in an easier way. It is suitable for time-critical jobs. It is most suitable for writing interrupt service routines and other memory-resident programs. The processor supports the following data sizes: word, a 2-byte data item; double word, a 4-byte, 32-bit data item; quad word, an 8-byte, 64-bit data item; paragraph, a 16-byte, 128-bit area; kilobyte, 1024 bytes; megabyte, 1,048,576 bytes. Every number system uses positional notation, i.e., each position in which a digit is written has a different positional value. Each position is power of the base, which is 2 for binary number system, and these powers begin at 0 and increase by 1. The following table shows the positional values for an 8-bit binary number, where all bits are set on. The value of a binary number is based on the presence of 1 bits and their positional value. So, the value of a given binary number is hexadecimal number system uses base 16. The digits in this system range from 0 to 15. By convention, the letters A through use 2, corresponding to decimal values 10 through 15. Hexadecimal numbers in computing is used for abbreviating representations. Basically, number system represents a binary data by dividing each byte in half and expressing the value of each half byte. The following table provides The following table illustrates 4 simple rules for binary. A negative binary value is expressed in 2's complement notation. According to this rule, to convert a binary number to its negative value through which the processor controls and the execution of instructions is referred as the fetch decode execute cycle or the execution cycle. It consists of 3 continuous steps: fetching the instruction from memory, decoding or identifying the instruction, executing the instruction. Assembly. Basic syntax. An assembly program can be divided into 3 sections: the data section, the BSS section, and the Assembly language programs consist of 3 types of statements: executable instructions or instructions, assembler directives or pseudo-ops, and the executable instructions are simply instructions tell the processor what to do. A segmented memory model divides the system memory into groups of independent segments referenced by pointers located in the segment registers. Each segment is used to contain a specific type of data. One segment is used to contain instruction codes. Another segment stores the data element. To speed up the processor operations, the processor includes some internal memory storage locations, called registers. The registers store data elements for processing without having to access the memory. A limited number of registers are built into the processor chip. There are 10 32-bit and 6 16-bit processor registers in IA32 architecture. The registers are grouped into 3 categories. General register, four 32-bit data registers are used for arithmetic, logical, and other operations. These 32-bit registers can be used in 3 ways: as complete 32-bit data registers, EAX, EBX, ECX, EDX. Lower halves of the 32-bit registers can be used as 4 16-bit data registers, AX, BX.
Should I learn assembly language programming?
Assembly languages teach you a lot about how microcontrollers and computer components work. You'll learn about CPU pipelining, cache alignment, how instructions are reordered.
Learning how to use a software application for making spaghetti-like flowcharts to explain logic and instruction flow would be useful, both on the PC and in meetings.
You'll understand security holes like the Stack Overrun, so you can structure your code to fill in those gaps.
I could get an IT security certification and higher pay rate without learning assembly code.
If you understand the assembly language, it can help you debug the code if you don't have the source code, and be able to decode the ASM dump.
I'd rather install a different application on the device.
If you want to create software applications, you don't need to know assembly language. If you're programming an OS, you need to know assembly language, because your code is going to talk to the printer, speaker, screen, hard drive and other devices.
I thought it was just Microsoft's fault.
Compilers create assembly language code. If you will be writing a compiler's code, you need to know an assembly language.
I'm not planning on going into that niche. Maybe apps or games.
If you'll be creating games or graphics-heavy software, you may want to know assembly languages to control the audio and video devices.
Or I could involve a hardware designer.
We live in a world where programmers are assumed to be working with PCs, while everything around us is getting smart.
I knew about a lot of the smart grid mandates flowing down, saying we all have to get smart meters in our homes.
If you'll be working on real-time embedded systems, you need to know assembly languages. That is true whether programming scientific calculators, smart power meters or medical equipment.
But then no one will know what applications I've created if I list them on my resume.
But the device you program will literally be everywhere. And since few people know assembly language while these devices are proliferating, the pay is pretty good.